Material handling and storage. In this section, we will be looking at the basic rules for storing materials and basic rigging requirements. This rule set is addressed in 29 CFR 1926, Subpart H. The objectives of this section are to review the basic rules for rigging, material storage, and the need and frequency for inspections of rigging equipment. Proper materials handling. Material handling includes the moving, lifting, and storing of materials. Handling materials properly means the movement and rigging of materials so that workers do not get injured. Prior to lifting a load, all rigging must be inspected by trained, competent people to ensure that it is safe. Rigging includes slings, chains, wire rope, natural and synthetic rope, and shackles and hooks. If any part of the rigging is defective, it must be removed from service. Once the rigging has been inspected, the materials need to be secured so the load does not shift, slip, or fall onto others. Always remember not to exceed the lifting capacity of the rigging or hoisting equipment. Rigging equipment. Slings and wire rope are often used for lifting. Rigging is a specialty skill and should not be attempted unless you are specially trained as a rigger. Damaged slings are commonly found on job sites as a result of improper storage, failing to protect rigging from sharp edges, shock loading, or from chemical and heat damage. It is very important to be able to read the labels and tags on rigging equipment, as it will provide valuable information about the sling's capacities in various load configurations. As seen in the bullet points in this slide, employers must ensure that rigging equipment has permanently attached manufacturer labels that are readable and indicate the intended load, not be loaded in excess of the rated load, and not be used when labels are missing or aren't readable. The picture shown on this slide can be used as an example of what you might expect to find during a field inspection. So in this case, we're seeing pictures of new equipment and damaged equipment. The picture on the left shows a new sling that has not seen service next to the same type of sling that has seen too much service. Note the fraying on the sling eye in the left picture and the permanent deformation of the nylon sling material in the right photo. Slings and wire rope. Under the rules for wire rope, if the number of broken wires exceeds 10% of the total number of wires in a strand, the wire rope is considered to be damaged and must be taken out of service. Manufacturers of wire rope may have additional criteria for when they consider their product to be unsafe for use. Kinks, crushing, bird caging, all are examples of damage that weaken the wire rope. If in doubt, throw it out. The photo shows a piece of wire rope with some distortion and some bird caging. In this photo, we can see a wire rope with several broken wires. You would want to count the number of wires in one lay, which is the distance for the strand to go around the core one full turn. And if this count exceeds 10% of the wires in the strand, the wire rope is considered damaged and should be immediately taken out of service. Hooks, shackles, and chains. A closed hook means that a latch or a keeper extends across the open throat, keeping a sling from accidentally slipping off the hook. Hooks with self-closing latches or their equivalent shall be used. The exception to this are J-hooks, or an open hook, are permitted to be used when setting wooden trusses. When working with hooks, if they're bent, twisted, or cracked, they must be discarded. These are solid metal objects, and oftentimes the cracking may not be visible to the naked eye, so when a piece of this type of equipment fails, it's often catastrophic. When working with chains, they need to be a alloy steel rated for rigging. This means you can't just go grab some chain off a spool at Home Depot or Menards. It has to be rated for rigging. Generally speaking, your do-it-yourself stores probably aren't going to carry the type of chains that you need for rigging. You might have some for load binding, but you'd want to get chains for rigging from an actual rigging store or warehouse. The photo at the top shows a hook on a chain that is missing the keeper. So in the case where you have a missing keeper, they're easily replaced with spring. It's just a matter of adding a new one to the hook, and you can see a replacement keeper to the next to the hook in the top picture. The bottom picture also shows a load that's rigged off of a crane. You can see in the picture, we can see daylight between the hook and the shaft of the hook. which means that there's no keeper there. In this case, those nylon slings that are looped over that hook, in the event that pressure was taken off of that load, maybe it hit when it was landing or got hung up on something, that could cause that sling to come up over the top of that hook and essentially wind up dropping the load. On this slide, we can see a couple more photos of some different types of rigging applications. In this case, we're rigging off a excavator bucket. In the picture in the top left, we can see that we have a auger that is being hoisted onto on or off of a flatbed truck, and you can see daylight through the hook, meaning that this is also an open hook. In the bottom right photo here, we can see a similar type hook, but in this case, you can see the silver keeper that is engaged on that hook to prevent materials from slipping off. On this slide, we're focusing particularly just on the hooks. So hooks shall be discarded if A, the throat opening is 15% greater than the original. The only way that you would know that is to have a spec sheet or cut sheet of the hook, or to have taken measurements of the hook prior to putting it into service. So in the picture in the bottom left, you can see a brand new hook. In the picture to the right, you can see the same type of hook, but you can note that the throat opening is considerably larger, and that's because it's been loaded, maybe loaded on the tip of that hook, causing it to stretch, essentially. If it's more than 15% greater than the original opening, it's damaged, it needs to be taken out of service. The other item is if the hook is twisted, right? So if you have more than a 10-degree twist, so if you were looking at the hook straight on, if the point of the hook were misaligned from the shaft of the hook, that would be a twist. And if it's more than 10 degrees, that's also damage. It will prevent the keeper from closing properly and would need to be taken out of service. Makeshift devices. We cannot use makeshift devices such as a hook, link, or fastener or other lifting accessory unless it's been tested and marked for a rated load. So in the pictures that you see here, neither of these devices would pass an inspection from a competent person. The pin in the shackle in the left picture, it's not properly threaded or secured in the shackle and would likely slip out. The picture on the right is a homemade device using flat stock, bar stock, and washers. This device has no rating and cannot be used as a rigging device. Chains. Chains must be of an alloy steel. They have to have a permanently attached tag showing size, grade, rated capacity, and the manufacturer's name. They have to be inspected at regular intervals and a record of the most recent month which an alloy chain was inspected, right? So you have to maintain an inspection log. Chains are examples of rigging similar to shackles and hooks that, because they are a solid steel type situation, you can get micro cracking in the chain links and they can fail on you unexpectedly and catastrophically. Stretching is a less common occurrence with chains. You may see some stretching periodically, but more often than not, when you load a chain to the point of stretching it out in the field, most alloy chains are going to fail under that type of load, and they will fail catastrophically. This slide contains a few of the rules related to the storage of materials on scaffolds, the stacking of loose bagged materials, and the storage of materials inside of buildings under construction. There are additional rules for the storage of materials in the scaffold and fall protection standards. So first, materials shall not be stored on scaffolds or runways in excess of the supplies needed for immediate operations. When stacking bagged materials, they have to be stacked by stepping back the layers and cross-keying the bags at least every 10 bags high. And 3, material stored in buildings under construction shall not be placed within 6 feet of hoistways or openings and shall not be placed within 10 feet of an exterior wall that is not taller than the stored material. The idea here is that we want to protect people working below from falling object hazards. As it relates to falling object hazards, this is a Focus 4 topic that we will get to next week. You have to use a 4-inch toe board around roof edges and scaffolds. That's a nominal dimension. So 2x4s, for example, are 3.5 inches, and that would be an acceptable toe board. You can barricade the area around the bottom of scaffolds to keep workers away from the hazard areas, so that if material does fall within the barricaded area, it's not likely to hit somebody. You also want to communicate with other trades through the use of signage, caution tape, or danger tape, depending on the situation, to communicate areas that are unsafe for workers to be in. When stacking brick or block, you have to stack bricks in a manner that will keep them from falling. Don't stack them more than 7 feet high. And you want to taper loose brick. So when you're manually stacking brick, you have to taper back loose brick stacks 2 inches per foot after it is 4 feet high. So when we think about the unimproved conditions that we have on job sites, they are often unimproved ground conditions where materials get stacked or stored. Uneven shifting of the ground or settling of the ground below the stacks of materials such as brick, block, and lumber can cause stacks of material to become unstable and result in material toppling onto nearby workers. Bricks and blocks should be limited to 7 feet in height. And as I stated earlier, when you're stacking loose block, you want to make sure that you taper those stacks back 2 inches per foot after it's 4 feet high. Similarly, lumber piles shall not exceed 20 feet in height when mechanically handled. All right, so if you're using a piece of equipment like a fork truck or a rough terrain fork truck, if lumber is to be handled manually, it shall not be stacked more than 16 feet high. Generally speaking, loose stacked materials like this on a job site, you're not generally going to see stacked that high. It's an unsafe condition. Most safety professionals out there in the field would not allow it, and likely you would have a hard time keeping them standing up on your job site if you stacked them that high. Manually handled lumber usually means broken bundles that are more likely to fall over during working operations or if the material becomes warped during exposure to the elements. Scrap lumber materials must have sharp protrusions like nails and screws removed or bent over to prevent puncture and laceration injuries. Material storage. So the slide here is pretty simple. You want to secure materials so they don't fall on workers, but the description, the reality is much more. All stored materials must be stored properly to prevent them from falling onto workers. Proper storage means that all materials must be stored in such a way that they do not shift, lean, or fall. They must be stacked, racked, blocked, and interlocked to prevent them from sliding, falling, or collapsing. Never store materials within 6 feet of a hoistway. Materials stored inside buildings under construction should not be placed within 6 feet of any hoistway or floor openings, nor within 10 feet of an exterior wall, which does not extend above the top of the material stored. Materials should not be stored on scaffolds in excess of the supplies needed for immediate operations. When storing materials that we picked up with a forklift or other mechanical means, place them on blocks so that the forks can get under them easier. Secure materials with bands to keep them together so they will not fall. And never stack materials on a surface that cannot hold the weight. Round objects such as pipes, bar stock may even need to also be racked or use specialized cribbing to keep them stable. You also want to maintain proper housekeeping in all of your storage areas. This means making sure that we keep weeds down, that we are not setting up those materials in a way that they become harborage for pests. Generally speaking, you want to keep the area free from trip or slip hazards, so garbage and things like that should not accumulate in these areas. You want to make sure that what we're really looking to maintain here is just a safe area where people are not going to be injured as a result of the material trying to walk across it or walk across uneven ground, or just a messy work area where slips, trips, strains, and sprains would be a common occurrence when working on uneven ground or whenever you have loose materials that somebody could step on and perhaps turn their ankles.